Welcome to qnawire.
Okay, so for this question, we can apply the energy balance equation. So if E dot in is equal to E dot out, if we expand it, we have a W dot in plus M dot times H1 minus plus V1 squared over 2 is equal to M dot times H2 plus V2 squared over 2, and then plus Q dot out. W dot in here is the power input, or in other words, the rate of work done on refrigerants. Okay, and the M dot here is the mass flow rate of the refrigerants 134A. And H1 is the initial enthalpy for the refrigerants. V1 is the inlet velocity for the refrigerants. And M dot here, I'm sorry, not M dot, H2 here is the final enthalpy for the refrigerants. And V2 is the exit velocity or the outlet velocity for the refrigerants. And when the Q dot is the rate of heat transfer associated with this process, which is the one we're looking for to determine. So if we do some arrangement here, we have Q dot is equal to M dot times H1 minus H2 plus 1/2 V1 squared minus V2 squared, and then plus W dot in. So in this case, we know the inlet velocity is negligible, which means that V1 squared minus V2 squared is approximately equal to negative V2 squared. So now we have a new equation for the Q dot out, which is M dot times H1 minus H2 minus 1/2 V2 squared plus W dot in. So for the initial enthalpy, we need to use the saturated refrigerant 134A table. So at temperature 10 degrees Celsius, we have the corresponding enthalpy is 256.16 kilojoule per kilograms. And we know the final enthalpy is given from the question, which is 281.39 kilojoule per kilograms. And we know the velocity square, which is the V2 square here, can be equal to 50 meter per second to the power 2. If we convert to kilojoule per kilogram, it's about 2.5 kilojoule per kilograms. And the power inputs, or the rate of the work done on the refrigerants is measured as 132.4 kilowatts. And we know the mass flow rate is 5 kilograms per second. So now let's plug it back to the equation to determine the rate of heat transfer associated with this process. So we have Q dot out is equal to 5 kilogram per second, and then times 256.16 kilojoule per kilogram minus 281.39 kilojoule per kilograms, and then minus 2.5 minus 2.5 kilojoule per kilogram over 2, and then plus 132.4 kilowatts. And this will give us the rate of heat transfer associated with this process is about 0 kilowatts. Okay, since it's 0, that means the process is an adiabatic process. And these are the answers for this question.